Hi everyone, my name is Lukyanov. I am Director of Product Management for GridGain Systems and a long-time Apache Ignite enthusiast. And today we will talk about security with Apache Ignite on the cloud. So what exactly we are going to talk about today? So first, I want to define our agenda as security in the broad sense, not just how we can provide passwords and authentication information to the database, but we will also talk about how do we deploy Apache Ignite securely, how do we protect data in Apache Ignite on the very basic levels. And then we will, of course, talk about the access control of the database. So we will try to look at security for Apache Ignite on these very different layers. And during our talk today, I will refer to different technologies in Apache Ignite ecosystem. So the first and foremost is, of course, Apache Ignite itself, Apache Ignite and its extensions, and Apache Ignite, of course, has a large number of tools and extension points and integrations that help you to secure your environments and secure your Apache Ignite installations. Then there is a well-known GridGain and memory computing platform, the product that GridGain Systems, our company, builds, which is built on top of Ignite, and GridGain platform provides additional tools and features for enterprise-grade security, availability, scalability, and performance. And today we will focus on the security features of GridGain and what it adds on top of Ignite to make the secure installation of uh, Ignite clusters easier. And then we will also talk about GridGain Nebula. GridGain Nebula is our software as a service solution. It's a cloud native managed installation of GridGain that comes pre-configured with a number of best practices already implemented with a large focus on security, and it also has additional integrations specifically for the cloud deployments that help you to integrate better with standard cloud security solutions. So throughout my talk today, I will generally go from solutions that are available with Apache Ignite to solutions that might be available as extensions delivered by GridGain platform. And then I will also talk about what GridGain Nebula adds in terms of features and also in terms of pre-installed, pre-configured best practices related to security. In other words, how do we as GridGain, as Apache Ignite experts, run Apache Ignite in the cloud securely? And so I will start with our first big section, which is the network and deployment security. So how do we deploy Apache Ignite securely, and how do we make sure that our applications connect to Apache Ignite securely so that we prevent any kind of network attacks, such as traffic sniffing or man-in-the-middle attacks, or any sorts of port scanning, etc. First thing that you really think about when you talk about network security is setting up a secure application perimeter. In an ideal world, at least ideal for information security specialists, everything that you have sits inside one single isolated network In a cloud environment such as AWS, it would be a single region, a single VPC, which is essentially a single data center in cloud terms. And then inside this single VPC, you have a single private network that contains all of your applications, your Ignite cluster, everything is there and fully isolated from the outside world. In reality, this is often not feasible, not achievable. You will often find yourself having more than one subnet, more than one VPC, or even more than one region, either because you're trying to split between different regions for high availability, or maybe because your uh, applications and your Ignite clusters are actually managed by different teams, maybe different departments, and they normally deploy to different VPCs. One way or another, you will likely find yourself in a situation when you need to connect to an Ignite cluster running in a different VPC than your application. And this becomes a not that trivial task. So we will take a look at a few typical patterns, a few typical network topologies that help to solve this problem. The first, the easiest one and the least secure one, obviously, is just putting Ignite into a public network. Public network means that other networks, other applications can just connect to this network. This network is available to the entire internet, essentially. We will rely on other security layers, such as firewalls, such as access control, to make this setup at least somehow secure. But of course, running a database in a public subnet is not really a production quality solution. But for illustrative purposes and just as a baseline, um, we are looking at this as well. In fact, even setting up this in a cloud environment with Apache Ignite might not be so trivial. There is certain magic that I don't want to get down deeply to, but there is certain magic with public and private addresses in the cloud that you would need to take care of. So this pattern is not secure and is easy, but not really entirely easy. The next one, the next pattern, which is probably the most commonly found for these multi-VPC architectures, is VPC peering. And VPC peering is known on different clouds by different names. AWS calls this a VPC peering, GCP calls this VPC network peering, Azure calls it virtual network peering. And what VPC peering is essentially merging two subnets that are in different VPCs into not a single subnet, but allowing these subnets to talk to each other and to route requests to each other so that there is a two-way communication there. This is much more secure than just a public network. Now, only these two subnets can see each other and talk to each other. This might be a bit more than you would want it to be, because maybe you need to connect from application to the Ignite cluster one way. You might not want Ignite cluster to be able to penetrate into your applications VPC, but this is still pretty secure, pretty much similar to a VPN connection, but a cloud spin to this. And Ignite is known to work in a VPC peering environment very well. Next, pattern that is even a bit more secure than VPC peering is using technologies such as AWS Private Link or similar technologies on other cloud environments. These technologies, they allow applications to connect to services deployed to different VPC, VPCs and networks, and even deployed in different accounts. How it works is the Ignite cluster becomes separated by a load balancer from the application, and near the application, in the application subnet, we deploy what's called a VPC endpoint, which is essentially a local to the application IP address that application talks to, and that is bound with transparent under the hood tunnel to the load balancer on the cluster side, and then load balancer sends the request directly to the cluster. And this is the most secure setup because it only allows the one-way connection, and we really only need a one-way connection from application to the database and not vice versa. And it is also probably the easiest one in terms of the network topology, especially for the application itself, because it sees the database cluster as essentially a local IP. So application doesn't even know that it goes to another subnet. So address management becomes a bit easier. But the downside with this, with the current Ignite architecture, is that such connection allows only thin clients, only thin Ignite clients. This is because thick clients of Apache Ignite cannot work over a load balancer. So with this connection, you will only be able to use thin clients, and you also won't be able to use partition awareness of thin clients. So this is a bit limiting, but also a bit more secure than previous options. And so if we look at our different solutions that we have in the ecosystem, so Apache Ignite and GridGain platform, both they work very well with all three of these approaches. So public network is pretty easy to set up, VPC peering and private link. End of the day, they don't have too much to do with Apache Ignite and GridGain platform themselves, with the clusters themselves. It's more of the networking and environment setup, which you need to do manually, but you can make it work with Apache Ignite for sure. And then on GridGain Nebula as a managed service, we have a choice of the public network or private link. The private link setup with Nebula is much easier than if you would set it up yourself, because everything just comes out of the box and there is a short instruction to follow to get it to work. So after we have set up a perimeter, and hopefully we did not go with the public cluster, but whether we went with a public cluster or whether we went with one of the solutions with a private network, even if we have a single VPC, so a fully isolated single network, it is always a good idea to additionally set up a firewall. There are basically two levels of firewalls that you can set up in most cloud environments. The basic level of firewall would be what AWS calls security groups, and Azure also says security groups, and GCP has a different name for this. It's basically limiting what connections can be established inbound and outbound for the cluster. And there is limited set of ports that Ignite usually listens to, which you normally set up as for inbound allow list, and outbound connections for Ignite. Many Ignite installations don't even have outbound connections. Some will have to like a third-party persistent storage and things like that. This level of firewall setup, the basic port-based inbound and outbound rules, I would recommend setting up just always. Then there is an advanced level, which is a traffic inspection, which can be pretty costly. These managed firewalls in cloud providers can charge, well, quite significant sum of money for their usage, and with them it is more of a judgment call, or more of whether or not you have certain policies and restrictions on how in your organization firewall needs to be set up, and whether this intelligent traffic inspection is absolutely required. So after we set up the firewall, the final bit of our network security will be data encryption. And one thing I will recommend is just always enable SSL or TLS. People often are afraid of enabling TLS, mostly because of performance concerns. Performance impact of TLS for Apache Ignite setups is usually pretty negligible. It's usually around single-digit percents, like low single-digit 1-2%. And this is not really something that you want to consider for compromising your security. Just enable your TLS. You never know who will be able to penetrate into your perimeter, into your environment, and start sniffing on your traffic. So having TLS is absolutely a must. Ignite, of course, also supports mutual TLS, so also known as two-way TLS, and Ignite and GridGain support essentially any type of TLS, any version of TLS, any algorithm that Java platform supports, which is, well, all modern algorithms, and this will surely be enough to comply with any sort of policy. On Nebula specifically, we have SSL TLS enabled by default out of the box for all connections. And we also have certificate management automated and taken care of as a part of the GridGain Nebula service. And with Apache Ignite and GridGain platform, if you manage your cluster yourself, it is, of course, a good idea to integrate with certificate manager software that is available with your cloud provider. So this was our first large block, the network protection, and now we transition to the second part, to the second block, which is data protection. How do we make sure that an attacker, even if they get access to our system, to our network, somehow get onto our host? How do we make sure they won't be able to steal our data, to change it in any way, and so forth? So the main feature to consider here is transparent data encryption that is available in both Ignite and GridGain. Transparent data encryption is encryption of data at rest that is as the name suggests, fully transparent to your application. Once it's enabled, application still works in exactly the same way. Key value access, SQL access, indexes, they all still can access the same data, and the data will be automatically encrypted and decrypted as needed. Uh, Transparent data encryption implements what's called an envelope encryption strategy when there is a so-called master key or key encryption key that is stored separately from the cluster, and the cluster itself stores the data keys that are themselves encrypted with this main key encryption key, and the data keys encrypt the data. And this kind of encryption, this envelope encryption strategy, is the strategy that will allow you to pass certifications such as PCI DSS. By default, out of the box, Apache Ignite and GridGain platform provide integrations only with JKS files, meaning that your key encryption key, your main key, will be stored in a JKS file local to your nodes, readable by your nodes, and you will have to implement some sort of management for this JKS file for key rotations, for just orchestrating delivering this key to all of your nodes and so forth. With GridGain Nebula, it is a bit easier in the cloud environment. In the cloud environment, you want to integrate with your cloud provider's standard key management service. For example, on AWS, it's AWS KMS, AWS Key Management Service. And GridGain Nebula integrates exactly with that, taking this key encryption key from there. And actually, the key encryption key is fully customer managed, so you're in full control of it. And the key rotation is, of course, also taken care of by Nebula and by the KMS service itself. So in addition to encrypting our data, which is the most important thing, the database level encryption, we have a number of other ways to protect our hosts and our data servers. And to name a few of these ways that we use in GridGain Nebula, and that you can also use in any of your Apache Ignite installations. So there is volume level encryption. In addition to database level encryption, you can also store the data on encrypted volumes, which is actually the default for many cloud platforms. For example, on AWS, the default way of data storage is encrypted block storage, which is encrypted out of the box. So you have encryption on your volume level and encryption on the database level if you need it. Then you need to design your system, operating system level, users and roles and access permissions on the operating system level, so that even if someone gets access on the system, maybe steals someone's password and is able to log onto the system, they won't be able to just do anything there, won't be able to get any privileges on that system. Then there is host level audit, which allows you to, if someone makes any action on the system, it will tell you who and when made the action. So if anyone makes any changes, you will know about that. You also need to take care of your logs, make sure that your logs don't contain any sensitive information, don't contain any just actual data, and Ignite has tools for that we in GridGain Nebula use. And there are more little things like this that you should take care of in your in your Apache Ignite environments. And the last but not least piece of our secure Apache Ignite setup is access control, which is what most people would think about when talking about database security. It's authentication and authorization. Here we have a lot of variety between different editions of Apache Ignite. So Ignite itself comes with authentication available out of the box. It's what's called basic authentication. So it's logins and passwords that you can manage through Ignite SQL. And it doesn't come with any of the additional features such as authorization, but it gives you this basic level of database level security, which can be enough. For example, if you have a single tenant Apache Ignite application and you maybe don't need authorization, but in most cases you will first need some authorization capabilities. You will need to be able to assign different roles to different users, to different applications, assigning them with different permissions. And then you will also want to integrate with external identity providers. No one likes to create a new set of users for a new set of um, for a new system, a new set of users for each set of applications and teams, etc. So most of you manage your users through things like Active Directory, or maybe you use something like Kerberos for single sign-on, or maybe you use some of the cloud tools such as identity account management on AWS. So GridGain platform allows you to integrate with any of these tools. Some of these integrations come out of the box, and then there is an extension point that allows you to easily build an additional integration. If you have another identity provider, you can also build this additional you can also build this additional identity provider integrations. And then once you set it up, you can also use database level audit. What it means is same as we talked about the host itself. If someone logs into the host, you can see what they did there. Same with the database. If someone runs a query, or if someone changes uh, some state of the database, some configuration, or if someone changes the data, you can catch these events and you can extract the user information, the user who initiated this action, and you can extract this and you can log this for further audit. And this is often a hard requirement from security teams in mission critical applications to have this kind of capability. So this is Ignite and GridGain platform, and then on Nebula we have virtually the same capabilities as with GridGain platform. Nebula also provides its own UI for user management to easily and quickly create new users, especially when you're just starting with a new installation, with a new database cluster. So this is it. We talked about network level security. We talked about protecting the data on the host with data encryption and with other steps and tools. And we talked about the database level protection, database level access control. So to summarize, if you want to secure your Apache Ignite installation, you start by figuring out what is the right network topology for you and how you can build the secure network perimeter for yourself. Then even if you've built a secure network perimeter, you still should protect inside this network with firewall and with encryption in transit with TLS. Then you need to protect your data on the host with encryption that is available in Apache Ignite as transparent data encryption. But you also want to integrate transparent data encryption with your cloud provider's key management service. Then you want to additionally protect the host with, well, essentially all the best practices for for your operating system, such as operating system level users and roles and permissions and so forth. Then you go to the database level and you define your users and roles with authentication and authorization. Here, Ignite provides some basic level of authentication, but for enterprise grade, production grade installations, you will probably want to go with something like what's provided by GridGain platform with authorization capabilities, with audit, and with ability to integrate with external identity providers. And finally, if you're running Apache Ignite on the cloud, if you want it to be secure, GridGain Nebula, which is a managed service for Apache Ignite installation, for GridGain installations, comes out of the box with pre-configured, installed best practice setups and features for security for Apache Ignite on the cloud. This is all I had for today. Thank you for your attention.
Great. Well, thank you, Stan. Stan, I'm going to get you back on the stage with me.
Hi.
Hi. So I see we have a question in the chat from Swapnil. I'm going to put that up now. So the question is, does Ignite use any service mesh like Istio or Envoy under the hood for GridGain or for Nebula?
Yeah, Ignite and GridGain don't use service mesh technologies under the hood. Well, both Ignite and GridGain handle their own networking and service discovery and SSL as well. So basically, networking layer is a part of the distributed system. Although I do know people who actually implemented GridGain in an environment together with Istio when Istio would take care of things like SSL instead of GridGain. So mixing is possible, but they are not under the hood by default.
Okay, great. Thank you. And then we have one more question here, which is, what are the differences between supply chain security in Ignite, GridGain, and Nebula offerings?
I'm not sure what exactly is meant about supply chain security. Is it meaning the supply chain like a business vertical? If it's about business vertical, then I would imagine it is for Ignite and GridGain as middlewares, and for Nebula as this middleware being on the cloud. I would imagine it is virtually the same. So we as middleware, we provide the basic capabilities for, again, for different types of deployments, for data encryption, data protection, and for access control. And yeah, different business verticals will use different policies and have different requirements on the kind of security they want to implement. But yeah, GridGain is known to satisfy them all, being able to satisfy them all.
I think that's it. Okay, great. Well, Stan, thanks a lot. Good to talk to you as always. Good to hear from you, and thank you for the presentation.
Thank you, Jeremy.
Um,
Thanks, everyone.